Today in the morning I had to make a decision. I had to decide what do I want to wear. Do I want to wear shorts, trousers, stuff like that? Did I make that decision? I made that decision based on 12,420 days of experience. If someone wants to calculate my age, feel free. Don't forget the leap years. The first few years, my learning on what to wear based on the weather, based on the location, based on the season of the year, were supervised by my mom. My mom said, okay, you have to wear trousers, it's winter, it's cold. My mom said, come on, wear shorts, it's warm outside, we have summer. After a few years, my mom let me choose my clothes alone. And every day she said, well, that was a quite good choice, and that wasn't a good choice. So I had the opportunity to check if my decisions were right. After a few more years, I was able to make a good model for my mom, that my mom could understand, a set of rules. So she said to me, okay, this rule said you can do your clothes today alone for the rest of your life. I think sometimes she regretted that decision, but never mind. What does that have to do with machine learning? And I think that, no, let's do it that way. Sorry. What does that do to have with machine learning? Today's talk is about how to do decisions in the browser. Who am I? My name is Martin. I work for idealo. That's a price comparison company. We sit in Berlin and we do price comparison in a few European countries. We have to do a lot with categorizing offers to different products and stuff like that, so we know a way around when it comes to categorizing stuff. I'm also the organizer of the Angular meetup in Berlin, so if you have questions about Angular or stuff like that, don't ask me now, maybe ask me later. Well, as said, I'm a little bit in love with Angular. I'm quite in love with math. I studied math, and I'm really in love with cats. So this is my cat. And this is my Twitter handle, and it is also the nickname of my cat, so yeah. For everybody who's thinking, who is the cat? That's me. So, what is a decision tree? Here's the definition of Wikipedia. And it's a little bit complicated, but it's a flowchart-like structure. You have internal nodes, and each of those nodes helps you to make a decision based on an attribute of your data. And if you're at the end of your tree, you have your leaves, and each of those leaves helps you to make a classification. So at the end of the node, end of the tree, you have a leaf, and the leaf tells you what the decision tree thinks this data wants you to say. It's a little bit complicated. You see I'm stumbling over the text. Pictures are a little bit easier. So that's a totally made up example. But let's say the first node of our tree is the decision, is it summer or is it winter? If it is summer, does the sun shine or not? Is it over 20 degrees Celsius or below 20 degrees Celsius? And at the end, you have the decision made by this tree to wear trousers or shorts. Quite easy. My mom could understand that. You can compress that to just Boolean rules. So you can make a Boolean rule that tells you if you have to wear shorts or trousers or stuff like that. But let's take a little bit of step back. That's one kind of machine learning. It's called the supervised machine learning. As we see, classification is one kind of example for supervised learning. Supervised learning is if you have a data set and you can label each data set and you'll train with known data sets. So back to my example with clothes. The first few years I was supervised, so I learned, okay, the sun is shining, and at the end I had to wear shorts. The next thing is unsupervised learning. You use that for clustering. If you have a lot of data and you don't know what data belongs to what data, you're going to cluster the data. You don't know what's inside those heaps, but you create a lot of heaps, and you know which data belongs to which data. The last one is probably the most hip one, the most known one. It's reinforcement learning. You can see that with neural networks. You can do that with your children. If you tell your children that something they did is positive or negative, they adapt their knowledge and their learning based on your positive or negative feedback. So neural networks, for example, they learn even if they were trained. They learn by each data. You use that for image recognition, and well, Google uses it to play Go because they can. Let's have a look. The idea of this chart is by Andre Lücke, and I really liked his idea. It's no scientific research behind it. It's just his and also my interpretation of various machine learning algorithms. How understandable are they? Are they really highly understandable or really complicated and you can't tell your product manager, okay, that's the result? Or what kind of complexity can they solve? And you see over there neural networks, not neutral networks, I'm sorry for that. Neural networks can solve really complex things, but even the people at Google or any other company doing neural networks have a hard time to understand what the networks do within themselves. You have, on the other hand, you have things like linear regression that's more or less just drawing a line in a two-dimensional or multi-dimensional data set. You have naive Bayes. Everybody who has ever set up a mail server knows naive Bayes because it is or was one of the most used algorithms to detect spam. So it's really good to detect if a text is a spam email or not. Here we have decision trees. I feel they're a little bit more understandable and a little bit more flexible than naive Bayes. You have classifications like random forest. Random forest, what is nothing more than just a lot of trees. A forest is multiple trees. Yeah, and I choose to do a talk about decision trees because everybody can understand them. You saw the tree, you can understand them. You can go to your product manager and tell them, well, I created this decision tree and here is the result. And he says, okay, I can understand that. Let's do that. So the next question is, why should we do it in a browser? Well, native apps, to be precisely, iPhone apps have a library called CoreML. CoreML is a library with a lot of pre-learned models for various machine learning algorithms, and they provide you with a lot of machine learning algorithms, so you can do machine learning on your iPhone, on your iPad. And if you're on a server, you can do TensorFlow. Everybody knows Google's TensorFlow and neural networks created with TensorFlow. And of course, there's also machine learning as a service, for example, by Azure ML. They also provide you a lot of pre-learned machine learning models and a lot of machine learning algorithms. So yeah, why do I use the browser? First of all, because I can. And the second two ideas I had for where to use machine learning or decision trees in the browser is PWA. Progressive web apps try to fit into a universe of native apps, so it would be good for them to be able to have the same possibilities like native apps. For example, native apps also have face detection. PWAs are not able to plug into that API, so they have to do it on their own. And I feel like offline first apps in general can have good possible solutions with decision trees or machine learning in general, because you can't use your server if you're offline. I made a few examples. No, I didn't make them. I just want to give you some examples where to use that. This example is basically based on a problem I had with a company working a few years ago. We had a really complex application, and you had multiple ways to get your data into the app and start process and stuff like that. And we encountered that our customers take various roads and routes to solve the same problem. And a lot of them said, well, everything is fine, we have easy click path, and some of them said, well, it's too complicated. So back then we sat together and had a lot of interviews with our customers and wrote down every every step they took, and we built a decision tree by hand back then and created the rule sets from that and implemented those rule sets in the browser to choose in our AngularJS application what link to show for the next step. It was a little bit of work, a month or so, 2 people working a month just to get the data and just to analyze the data. Another possible solution would be preloading for lazy scripts, especially if you preload. For example, in Angular, you have preloading strategies, and it can be really good to make the decision if you want to load a script element, no, not an element, a module, by decisions that are made based on data. You can save volume for your users, especially on mobile, because every megabyte you send to your customers costs them money based on what land they are in, country they are in. It costs them more or less money, but it costs them money and time. So if you have a big application, you don't want them to load the settings module every time they go to your site. You don't want them to load the context module if you're not doing anything special with context. But you want to know what to preload to make the UX, the UI better for them. Also, a really good example, this one, the idea to this example is really, really old. I've seen the idea of making shortcuts based on shapes, geometrical shapes. I've seen that idea back before the first iPhone with my first kind of smartphone. It was a Nokia phone, and you were able to do shortcuts into apps by just drawing a rectangle or a triangle or a circle or stuff like that. And if you're on a mobile phone, you can't do shortcuts, keyboard shortcuts. Every good web application should have keyboard shortcuts to help the power users to get around easily and fast. But on a mobile app, you can't do shortcuts because you don't have a keyboard. But you could use that technique to create shortcuts based on geometrical shapes, for example, doing a snake-like form for saving that data. So we talked about what is machine learning in general, what are decision trees specific, they are supervised machine learning. We talked about a few examples. Let's talk about do decision trees in the browser. You have to do 3 steps, more or less. You have to collect your data. There are various forms to collect your data. You have to train your model, and you have to test your model. And you have to know what you're seeing if you test your model. And of course, you have to use it in the end. You have to classify data. So let's start by collecting data. Most of the data you can collect are, for example, by your analytics tool, if you use Google Analytics, or if you use WebTrack or something like that, you get CSV files. So CSV files are often a good source for collecting data. And I built a tool to do all the decision trees in the browser, and the first thing I had to do was to transform CSV files or CSV strings into my internal JSON format. I made it really easy for you. I created a function. The code I wrote is not in JavaScript, it's in TypeScript, and it makes it easier to do the stuff, in my personal opinion, and it makes it easier to show the API. So I have a function, you give it a CSV string, and you get a big JSON object with all the CSV data inside it, so you can use it afterwards. So besides from CSV, you're also, of course, allowed to collect your data inside your browser and collect them in the perfect format at the end, or you can do your own converter. But first of all, you have to collect data. You need about at least 50 data sets to do any good machine learning. Let's say up to 100,000 data sets is a good size for how to do machine learning with decision trees. And you need those data to train them and, of course, to test them. The first thing you have to do if you train them, use this function. You give them the data set you created just a few slides before. We'll talk about the pruning parameter a little bit later, and you get back the root node of a decision tree, and you can use that decision tree later on. So how does it work? How do you train a decision tree? I don't want to do math up here because I think everybody will hate me if I do math up here. So I will just talk about how to do it in general with decision trees. First of all, you go to through all your attributes of your sample. So if you think about the CSV file, you have a lot of columns and a lot of rows. And you go through the columns. Each column is one attribute, and you create a node based on that attribute. So you decide based on that attribute if you go to the left or to the right. And you repeat that until you don't have any more attributes. So you will say, okay, but which attribute, which feature do I use next? Do you use the first column and then the second column and then the third column? If you would do that, the tree would always be the way you present the data to the algorithm, but you don't do that. You don't do that. You don't do it from the first to the last column. You have a little unicorn called entropy, and entropy comes by and tells you what's the best next feature to take. So entropy is a little bit of math you have to do to calculate of all your remaining attributes, which of them has the most information for you. So if you come back to our example about wearing trousers or shorts, it can be that the definition of the season is more important than the definition of the place you are. For example, if you're in the Western Hemisphere, it doesn't matter if it's summer or winter or other way around. But if the sun is shining or if it's raining, that can be more important to make a decision if you want to wear trousers than the temperature. So entropy tells you what is the best next feature. And you do that over and over again until you have no attributes left. And you create a tree. You started with one decision. You have, for each of the subsets, you create a new subtree and so on until you only have leaves left. So the next thing is, after training your data set, is to know if your decision tree, the tree you built, is good. So first thing is we want another sample set. We don't want to use our decision tree, the model we created, in the wild without knowing if it is good. So we have the sample sets where we know the labels for each data set, and we try to split that. So we have two data sets, one only for training and one only for testing. We want to go, well, splitting. I also created a little function to do that. This function takes the sample data sets and gives you back two data sets. Based on the samples should be randomly selected. So you don't have the first few hundreds and then the next few hundreds. You want to do a little bit of randomness inside there, just to not make your tree a little bit weird or stuff like that. And if you split your data, you have two data sets. You can do that over and over again if you want to. If you have enough data, you can split multiple times and test multiple times and train multiple times to make it more and more precise. But in the end, you just want to know how accurate your decision tree is. Also, easy function. You calculate the accuracy, you give it to node of your decision tree, and you test data. The test data needs to have labels, so you need for each column of the test data, you need to know what the correct outcome would be. And you get back accuracy, so that's just percentage, the number of correct hits, and the total number of hits. That one is just a little bit of math with the other twos. So what are we looking at if we look at those data? We look at a tree that could be underfitting, like this one. No, doesn't work. Like this one. Or we could have a tree that is overfitting. If our tree is overfitting, we hit every point of our data. If our tree is underfitting, we just draw, for example, one line and don't find the perfect optimal solution. So if we want to talk about the accuracy of our tree, we have to think about two things. We have to think about the bias and the variance. Bias is more or less just the arrow when your model is too simple. We had on the left side, we had a too simple tree, and we couldn't make a good assumption how the data look like. Variance, on the other hand, is the arrow if your model is too close to the data. You saw on the right side, you saw a tree with a lot of nodes, and that tree could fit almost every node, every data set we had. So we don't want high bias or low bias. We don't want high variance or low variance. We want to be in the middle. We want to be in the optimal zone. How do you tell if you're in the optimal zone? Based on your accuracy. You calculate how many hits you have correct on your based on your training set in your test set. Perfect fit would be 100%. If you see 100% there, you did something wrong, because decisions are not always optimal. So 100% feels like you have a high variance. You can get 100% if you test your decision tree with the same data if you used to do the training, for example. On the other hand, if you, for example, have just two outcomes, two decisions, two labels, yes or no, true or false, blue or green, something like that, The worst outcome would be a coin flip, so 50%. So your accuracy should be between 50%, that's the worst, you have a high bias there, or between 100% where you have a high variance. So let's say 75% something like that. You have to get a feeling for that, to be honest. That's a little bit of kind of magic. We have underfitting, high bias, low variance. What do we do to solve that? We need more data. If you train a tree with 10 data sets, you will get not enough knowledge about the data set to do good decisions. The other one is overfitting. That is low bias, high variance. And this is where, if you remember the pruning parameter, that is where pruning comes into place. So what we do, we remove parts of the tree. We say, okay, that's too close to special data, ignore it. Just take the best, the highest choice on that subtree and remove a lot of the subtree. We are almost finished. The last thing we have to do is to use this tree we built in our day-to-day work in our browser. Also, one function. We classify our data. This one is not labeled data. It's just a data set you have once. For example, if you listen for the touch movement for shortcuts, for example, the sample would be the position of the mouse, of the touched mouse, and your decision tree would be pre-trained and given to the user as one data set, and the classifier just goes through this tree, and if it hits a leaf node, it will tell you what is in that leaf node. Like not getting the right label. So you have to have a plan B. You have to do, and that's not only with browsers and not only with the code I wrote, that's with every machine learning. You have to have a plan B. Please don't do things like putting people into a specific insurance based on their data, based on a machine learning algorithm. You need to have a plan B. You need to be able to allow your users, your customers, to decide differently than your machine does. That's one of the big things. Please don't build a heart transplantation software based on machine learning and you're not able to solve the heart transplantation for a little kid because the machine learning algorithm says no. Please make the possibility for users, for humans, to change the outcome of a classification of a decision. And I also have to have a plan B. I wrote all the code, but I decided to not make it open source yet because I'm still lacking a lot of documentation. I want you to understand the code based on the documentation and not only based on this short presentation. So I do it the Apple way. I hope I fixed you all to use machine learning and decision trees in the browser. And I will release the code in mid of October. Thank you very much.